right, so this is part 3. We're going to be looking at pages 11 through 16 of our study guide for our second semester review. All right, let's get into it. Blank, a structure that is no longer useful, okay, but it's leftovers. This is going to be vestigial. Test question. Blank structures are found on different organisms and have same structure but different functions. Okay, this is going to be homologous. These are things like a bird wing and a human arm. Okay, the same structure, bones inside, but not. Analogous, however, are going to be same function. So analogous. Ooh. Thank you, eraser. Okay, an example is going to be a bird versus a bee wing. One has bones, one uses something else completely different, but both used for flying. How often an allele or trait occurs in a population? This is going to be our allele frequency. Okay, so our frequency. Blank, when people control which organisms survive and reproduce through breeding. This is called artificial selection. Okay, so like dog breeds. Blank, similar organisms can breed with each other. Okay, so this is going to be a species. Blank, a change in allele frequencies over time. This is what we call evolution, or theory of. Okay, blank, evidence, usually in rock. This is going to be a fossil, so we're looking at things that are buried. Okay, looking at things that are buried. 2 frogs live in a forest. 1 frog has super sticky toes and can climb trees easily. Okay, right now I'm thinking off the bat. Oh, separate question. All right, never mind, moving on. Okay, 1 frog has a super long, narrow tongue. A large storm comes into the area and kills most of the bugs. The only bugs left live deep in the cracks of tree roots. According to Darwin's theory of natural selection, the individual whose inherited adaptations maximize fitness, okay, will survive and reproduce. Explains Darwin's idea in your own words using the frogs mentioned. Okay, so we're looking at bugs and which one's going to be able to kill or to consume the most bugs. So the only bugs left after this natural disaster are going to be found in the cracks of tree roots. Okay, so we're looking at which one's going to be able to stick their tongue down the tree roots. So in our case, we are going to say that the frogs with the long, narrow tongues will have a higher fitness because they can reach the bugs. And since it's on the roots, we won't need to climb. A mutation introduces a new tail spike on the end of a lizard's tail. Okay, so if the spike helps a lizard catch more prey, will the frequency of lizards born with tails go up or down? Up. If it makes it harder for the lizard to slide under rocks and hide, will it go down? Or up? Down, because it's not going to be able to hide from predators. If the spike is attracted to females, it's also going to go up. Sexual selection, like peacocks. Does the tail spike create more alleles for reproduction? So does the tail spike create more alleles for reproduction? Yes, because before there was no spike. Now when we add this, we're going to have one with a spike. So we see, yes, it is. How does genetic variation help organisms survive and reproduce? Well, different traits. Okay, so we're thinking about different traits. Give some creatures, right, or organisms, an advantage. Okay, so we're going to have an advantage. Darwin spends a long time studying the Galapagos Islands, where he's looking at different finches. What did his study reveal about bird beaks and foods? Why don't all birds have the same type of beak? Well, depending on the seeds available, right, this is going to drive the different types of beaks. If I have very small seeds, I need a smaller beak. If I'm going to need to break in there, I'm going to have larger beaks. If species did not change over time, we would expect to be looking at fossils that were the same. Okay, so we're going to be looking at fossils that were the same as previous. Okay, but we know that's not true. Okay, so we can see fossils. It's called the fossil record. So what would you expect to see? We'd expect to see the same fossils or same types of things living today as back then. Fossils would match today's dead and decomposing creatures. If species do change over time, what would you expect? Well, we're going to see some variations. Okay, so we're going to be seeing different types of fossils, different organisms. All right, use the cladogram to answer the questions. Which species share a common ancestor with the chordates? Okay, so I'm going to be looking for chordates. So chordates are going to be my vertebrates. In this case, which species share a common ancestor with the chordates? Okay, so here are my chordates. Anything branching from this node, I'll call it A. So all of them. Which have the most recent ancestor with amphibians? Well, these are going to be guys like reptiles and birds. So I'm going to have my reptiles. Blank. Which have the most recent common ancestor with reptiles? Birds. Which has the most recent common ancestor? Bony fishes. Okay, so here's my bony fishes. And reptiles. Or, okay, so I'm looking at or, jawless fish and sharks. So look at the number of differences, right? So there's 0 spaces here. There's a 1 space here. So the one that is going to be the closest will be my bony fish and reptiles. Okay. This is another test question. And interpreting a cladogram as well is going to be another good skill for you to have. All right, food web. Use the food web shown to answer the following questions. Is the relationship between a fox and a hare direct? Fox and a hare, yes. Why? Because it is directly interacting. Is the relationship between a moose and a pine tree direct or indirect? Well, he's going to be, this is the pine over here. This is going to be a spruce. I just know because of the way it is. Indirect. Is the relationship between a fox and an oak tree? Well, I know that all of the direct relationships would be here, so it must be indirect as well. Scientists were studying the forest ecosystem and noticed that when the amount of foxes went down, okay, vegetation also went down. Why? Because the foxes controlled the primary consumers' population. Without foxes, there's going to be more squirrels, more hares, which means that they're going to eat more plants. Name one animal that would compete with the hare for resources. Well, squirrels, also moose. Okay, so we're looking at the squirrel or the moose. The raven is connected to the moose because he basically cleans up the antlers. Okay, that's a different type of relationship. That's going to be commensalism. One benefits, one doesn't really care. Or you could argue for mutualism. The moose does nothing to help the raven. Okay, so that's actually going to be commensalism. But did not mind. What type of relationship? Commensalism. Label if the size of a population were increase, decrease, or stay the same. Birth rate decreases. Okay, so I'm going to have less people coming in, and death rate increases. It's going to decrease. Birth rate increases, death rate increases. Stays the same. Or maybe I'll write it out for you. Same. Birth rate remains the same. Okay, and death rate remains the same, but we're going to immigrate in, so it's going to increase. Birth rate remains the same. Death rate remains the same, but several leave. Okay, so I'm immigrating. Okay, so this is going to decrease population. Immigration birth rates are even with death rates and immigration. Okay, so I'm going to have two things be equal on one side and two things be equal on another. Things are going to stay the same. Draw a food chain with a turtle, zooplankton, small fish, algae, crane. Okay, label each one. Well, I will tell you that you're going to have your zooplankton. Okay, they're likely going to be eating your algae. Then you're going to have your small fish. You're also going to have a turtle. Crane. Not going to eat the turtle, but he will eat the small fish. You could also see something maybe like this. Okay, make sure you draw better than I do. Look at the food chain you just drew and answer the questions. Okay, correctly label producers, consumers. So again, producers are going to use the sun to make energy. Primary consumers are going to eat directly producers. Secondary consumers eat primary consumers. Tertiary eat the secondary consumers, and quaternary eat our tertiary consumers. At which level of the food chain will most energy be found? Producers. Test question. At which level of the food chain will least energy be found? In this case, it would be the quaternary. You will not need to know that, but you will need to know as high as secondary. At which level of the food chain will the greatest number of organisms appear? Producers, because there's more number of energy there. At which level of the food chain will be least number of organisms? So it's going to be the top, so to whatever the top consumer is. Approximately what percentage of energy is passed? So that's the rule of 10%. What percentage is lost? Okay, so that's going to be 90%. We're going to lose it in the form of heat and some other